A financial services firm needs an architecture to process a high volume of trades. You must implement a secure, message-oriented queuing solution that triggers automated jobs. These jobs, residing in Google Cloud, will invoke an internal Python-based API to complete the trades. Which implementation approach offers the most efficient design? Option A. Utilize a pub/sub push subscription to invoke a cloud function that handles communication with the Python API.
Option B. Deploy a custom application on a compute engine VM that performs pull-based subscriptions to a pub/sub topic. Option C. Develop a custom queue structure within a managed NoSQL database to store and process trade events. Option D. Use a Cloud Composer workflow to subscribe to a pub/sub topic and subsequently trigger the Python API.
When thinking about this question, consider how Google Cloud handles event-driven architectures, asynchronous messaging, and serverless compute triggers. We want to understand how different services balance operational overhead, scalability, and performance when processing high-frequency data streams. In my view, the correct answer is option A. pub/sub is the industry-standard choice for handling high-volume asynchronous messaging in Google Cloud. Using a push subscription to trigger a cloud function is the most efficient and scalable architectural pattern because it is serverless, meaning Google handles the infrastructure scaling automatically based on the volume of incoming trade signals. Looking at why the other options are less effective, Option B requires manual management of compute engine instances to pull messages, which adds unnecessary operational overhead. Option C involves building a custom queuing system on top of a database, which is complex, prone to errors, and lacks the native reliability features like retries and acknowledgements provided by pub/sub. Finally, Option D uses Cloud Composer, which is managed airflow. This tool is designed for complex workflow orchestration rather than high-frequency event triggering, making it both over-engineered and less performant for this specific requirement. As an exam tip, always favor serverless, native event-driven integrations for high-throughput, asynchronous workloads on Google Cloud.